Hello, and thank you for joining us for the Erb Street Wells Iron and Manganese Treatment Upgrades Public Consultation Center, or PCC. The purpose of this PCC is to provide an overview of the project and why it's important, describe the municipal class environmental assessment process, and provide a description of the existing Erb Street wells. A PDF of this presentation, including a transcript and additional information on the project, is available on the Region of Waterloo's website if you'd like to review it in more detail. A link to the website is provided in the video description below. We encourage you to review the information and contact a member of the project team by phone or email if you have any questions or would like to provide your thoughts to the project team. Contact information is provided at the end of this presentation and on the Region of Waterloo's website. To better understand the project, we ask the following three questions. 1. What are we doing? 2. Why are we doing it? And 3. What does it mean to you? To answer the first, the region is planning upgrades to the Erb Street Water Supply system to provide treatment for iron and manganese. This study will look at the best ways to complete these upgrades. Why are we doing it? Health Canada has recommended more stringent aesthetic drinking water objectives for manganese, and Ontario's drinking water standards are expected to change to meet the recommendations. The Erb Street Water Supply system has been identified as requiring upgrades to meet these future aesthetic objectives. As an aside, aesthetic objectives are targets we meet when treating water for taste, odor, and color. We are taking steps now to ensure that we are ready to meet these objectives. What does it mean to you? These upgrades will require a new building for the treatment equipment. It is expected that additional property will be required. There is no change in the amount of water being taken from the Erb Street Water Supply wells. Iron and manganese are naturally occurring metals commonly found in soil and are often found in drinking water that comes from underground wells. Iron and manganese may have aesthetic impacts, such as staining of laundry and fixtures, undesirable taste, and discoloration. The province of Ontario regulates standards for drinking water to protect health, and provides aesthetic objectives to produce drinking water that is pleasant to consumers. The province is considering a reduction to the manganese aesthetic objective in drinking water from 0.05 milligrams per liter to 0.02 milligrams per liter, based on guidance from Health Canada. As stated in slide 5, the Erb Street wells have been identified by the Region of Waterloo as requiring upgrades to meet future aesthetic objectives. The Municipal Class Environmental Assessment, or EA process, is a 5-phase planning process that is approved under the Ontario Environmental Assessment Act. All municipalities in Ontario are required to complete a Municipal Class EA when planning for major infrastructure projects. This project is being planned as a Schedule C project, which means it follows all the steps in the planning process. These steps include identifying the problem or opportunity, developing and evaluating alternative options, developing and evaluating alternative designs or how to best implement the solution, documenting the decision-making process in an environmental study report for the public and stakeholders to review and comment, and implementing the recommendations through design and construction. We are currently in phase 2 of the study and have identified alternative options and a preliminary recommended option, along with preliminary recommendations for water treatment technologies and preliminary water treatment facility locations. The second PCC will take place during phase 3, which is tentatively planned for the fall of 2020, where we will provide more information on the evaluation of alternative locations and preliminary recommended design for the treatment facility for public review and comment. There are a total of 5 wells located at 1226 and 1211 Erbs Road. After the water is disinfected, it is collected at the existing reservoir at 960 Erb Street West before entering the region's water supply system and to homes and businesses throughout the region. We've considered and screened a number of options for addressing the iron and manganese treatment requirements. Do nothing. This would mean that no treatment upgrades would be implemented. While this wouldn't meet the new drinking water quality objectives, we always consider this option as a baseline against other options. Identify a new water supply. This would mean finding a new source of water with water quality having no or low concentrations of iron and manganese. Existing well records throughout the region show that a new well would still require upgraded treatment requirements for iron and manganese. This is not a viable option, since well records throughout the region indicate that other well sources are likely to have similar iron and manganese content. New treatment building at the existing well sites. This would mean building a new treatment facility at the existing well sites. While this would allow the region to use their existing infrastructure and property, this is not a viable option since the existing sites do not have enough room to construct a new facility. New treatment building at a new site. This would mean building a new treatment facility at a new location. Water from the existing wells would be piped to the new facility for treatment before it enters the reservoir and the region's water supply system. Based on the screening of the 4 options, this is the preferred option. Next, we've looked at different treatment technology alternatives, as well as alternative locations for the new facility. We started with a long list of alternative sites for the new treatment facility around the existing wells and reservoir. We narrowed this down to a short list of sites based on a number of criteria. Appropriate land area for the new building and driveway, appropriate vehicle access to the new site, located close to the existing Erb Street Reservoir and connecting water mains, located outside of environmental and cultural heritage features, and existing and potential future land uses. The short list of alternative sites is shown on the map on your screen. We will be undertaking more detailed environmental reviews, including archaeology and natural heritage, and each site will be evaluated based on a number of criteria that address the socioeconomic, cultural, natural, technical, and economic environmental components. We will present more information on these environmental reviews and the evaluation of sites at our second PCC. There are a number of different ways to treat iron and manganese in drinking water sources. We reviewed a long list of alternative water treatment technologies and screened these to 3 different technologies. Traditional oxidation and filtration. This option involves adding a solution, such as chlorine, to water to oxidize the iron and manganese before removing it with a filter. This is a common form of water treatment that the region uses at other facilities. It would require a moderate building footprint, about 900 square feet, to account for new mechanical equipment and has a lower capital cost compared to other shortlisted options. Biological oxidation and filtration. This option involves oxidizing the iron and manganese using bacteria before removing it with a filter. This option is less reliable than traditional oxidation since the bacteria is sensitive to things like nutrient concentrations and other biological elements. It would also require new chemicals and operating procedures that are not currently used in other region facilities and would have a larger building footprint to accommodate the treatment requirements, approximately 1,000 to 1,300 square feet when compared to traditional oxidation and filtration. Ion exchange. This option involves replacing manganese ions with other ions through a chemical reaction. This process is less complex to operate than biological oxidation and filtration, but is less effective when there is a high concentration of particulate manganese in the water. It is not currently used in other region facilities, and it would have a larger building footprint to accommodate the treatment components, approximately 1,000 to 1,100 square feet. After evaluating the different treatment technologies based on natural, social and cultural, technical, and economic considerations, traditional oxidation and filtration has been identified as the preliminary preferred treatment technology. Some wastewater is produced using the traditional oxidation and filtration treatment method. This occurs when water is used to clean the filters by reversing the normal direction of flow. This is called backwash water, and it contains small concentrations of iron and manganese. Over time, most of the manganese and iron will settle out of the solution. How we deal with this leftover wastewater is called residuals management. For the Erb Street Water Supply, there are two feasible options available for residuals management. An equalization tank stores the backwash water while the iron and manganese settle to the bottom of the solution. Some of this water is recycled back to the start of the treatment process, and the settled iron and manganese material would be removed from the site by a truck every 1 to 2 weeks and disposed of at a local landfill. Another option involves the same process. However, instead of removing the settled solid using a truck, the wastewater is discharged into a sanitary sewer for treatment, along with other wastewater at the downstream Waterloo wastewater treatment plant. We will be evaluating the approaches to residuals management and will present preliminary recommendations at our second PCC. The next step for the project team is to receive your input on the information presented today. We will then continue with our environmental investigations, evaluate the alternative treatment facility locations, and evaluate residuals management approaches. These findings will be presented at our second PCC along with proposed environmental mitigation measures. We will then document the decision-making process, including the community input we've received within an environmental study report, which will be made available for public review for at least 30 days. Following the planning process, the region will move forward with the design process in 2022 and plans to start construction in 2025. Do you have any questions about the information presented here? Would you like more information on the alternatives or on the evaluation process? There are many ways to get in touch with the project team. You can fill out a comment sheet available on the region's website and return via mail or email to a member of the project team. Or you can contact a project team member directly by email, telephone, or mail. Kevin Delishny is a senior project engineer with servicing and development planning within water services at the region of Waterloo. His mailing address is 150 Frederick Street, 6th floor, Kitchener, Ontario, N2G 4J3. He can be reached by telephone at 519-575-4757, extension 3862. He can also be reached by email at kdelishny@regionofwaterloo.ca. Neil Harvey is a senior project manager at Stantec Consulting Limited. His mailing address is 300 Hagee Boulevard, Unit 100, Waterloo, Ontario, N2L0A4. He can be reached by telephone at 905-381-3234. He can also be reached by email at neil.harvey@stantec.com.